Okay, here's the second method, the second much better method for measuring the specific latent heat of fusion of water. If you remember in the last lesson, we did the method where we used the immersion heater, and it wasn't a brilliant method. I mean, it gave us a much overinflated value of specific latent heat. I think we had about a 70% percentage difference with the value it should be. Right, this method is much better, and this is actually my all-time favourite A-level physics prac. There's a number of reasons why I like it. The main one is it's absolute genius in its simplicity, and it also gives you a very accurate measurement for L. So I'll just talk you through it. We're going to melt ice again, but instead of using an immersion heater, we're going to use room temperature water. Okay, and what we're going to do, we're going to take a known mass of ice, melt it in room temperature water, and we're going to measure the temperature drop. Because this time, the melting ice is going to get its energy from room temperature water, and that energy is going to go into melting the ice. Now we can measure that exact amount of energy we get from the room temperature water by using the specific heat capacity equation. As long as we know the exact temperature drop and we know the mass of the water, then we can use a calculation, do the calculation, find out the value of energy lost by the water, assume that that all goes into melting the ice, and we can come up with a pretty, as long as we know the exact mass of ice as well, we can find an accurate value for L. So let's see what we can do here. But first thing we need to do, the crushed ice is in here, but we want to take our ice first before we melt it in the room temperature water. We want to take the crushed ice, okay, and just put it in a filter funnel first. All right. Any ideas what that's about? Right. Well, the reason is we want our crushed ice to be at 0 degrees Celsius, don't we? There's no point in taking ice that's at like -10 or -20 and then putting it in the water, because some of the energy taken from the water is going to go into heating the ice up. We want to measure the energy, only the energy that goes in to melt the ice. So, just to set the scene, the room temperature water here is 26.9 degrees Celsius. Okay, right, first measurement for you to write down is the mass of the empty beaker. So mass of the empty beaker, 106.17 grams. Hopefully you can see that there. So 106.17 grams. Right, we're going to put some water in. Okay, just put that there for a second. So we've got our trusty Pasco temperature sensor with the Chromebook running the software. Right, now I'm going to fill it up to about 150. Okay, doesn't have to be exact because we're going to measure the mass on here. So, new mass, the mass of the water, room temperature water plus the beaker is 246.65 grams. 246.65 grams we'll go with. Right, that's going to go there. Temperature sensor is going to go in. Now we're going to start recording. In the SparkView software, what I've slight difference, I'm going to tabulate the results and graph it at the same time. So starting temp is 26.7 degrees Celsius. So we're just going to wait for the temperature of the sensor to match the room temperature water, and then we're going to melt some ice. Right. One of the things we have to think about here is speed, because we can't just take all day adding ice to the water, because obviously this water will absorb heat energy from the room. So we want to be fairly quick, so we're going to be mindful of how much ice we're going to go in, but I think we're ready to go now, so it's just a case of, okay, pretty confident that our ice is as warm as we can get it before it all starts to melt, so it's as simple as this. I think that's melting pretty quickly. And we'll go with that. And then give it a quick stir to try and melt the ice. All the time, the temperature drop is going to be accurately measured in the SparkView software. So like I said, the trick here is being quite quick. As soon as we're confident that all the ice has melted, we'll get this back on the top pan balance, and then we're in business. Looks pretty good. Looks pretty good. Right, so if I stop that recording and make sure all the water is off the temperature sensor, and then we can have our final mass reading. So mass, new mass with the melted ice is 276.42 grams. Temperatures, right, looks like we had a final temperature of 11.8 degrees Celsius. Okay, 11.8 degrees Celsius. We had a starting temperature, didn't we, of, right, that's going to go all the way to the top. Boom, starting temperature, yeah, like I said, 26.7 degrees Celsius. Okay, so starting temp 26.7 degrees Celsius, final temp 11.8 degrees Celsius. Right, I think we've got some calculations to do. Thank you very much. I'll just give you a little close-up of the screen before I start the video. Okay. Right, thank you very much.